watch the video of minimization techniques in digital electronics. Several minimization techniques that are available. This BooleanAlgebra, so it helps to simplify the logic circuits. The drawback with the BooleanAlgebra is due to its lengthy mathematical operation, it is difficult to use for more than 3 variables. So we opted for kmap. Kmap, the full form for kmap is Karnaugh method. So it helps to simplify the Boolean expression when it is more than 3 variables. So up to 4 variables, it is very easy to solve with the help of the kmap. But when it exceeds the 4 variable, then we should opt for the Queen-McKelvey method. As we see about the kmap, the input variables are expressed in both POS and SOP forms. Okay, so the cells are filled by given input variables. So if there is a n input variable, means total number of cells is 2 to the power n. So if the input variable is 2, means then the total cell is 2 to the power of 2. So it's 4. When it is 3, it is 8. So when the input variable is 4, the total number of cells are 16. When it is 5, the total number of cells are 32. So the cells are combined by 16, 8, 4, 2 and 1. Okay, so cells cannot be combined other than this. This is a one variable combination. So one variable means either it is a 0 or 1. If it is a 2 variable means AB. So there are 4 combinations. If it is a 3 variable means 2 to the power of 3, 8 combination. So 3 variables represented A, B and C. So it starts from 0, 0, 0 to 111. Okay, so for 4 variable there are 16 combination. Okay, so A, B, C, D, these are the 4 variables. So it starts from 0, 0, 0 to up to 1111. These are some rules of the Boolean expressions. So for OR operation, AND operation and for NOT operation. 2 variable kmap. So how we locate in the cell? So we should form 4 boxes, as it is a 2 variable means 2 to the power of 2. So the combinations 0, 0, 0, 1, 1, 0 and 1, 1. So we can draw a box with the 4 cells. So here it is A, here it is B. So we should write 0, 1 here, 0, 1 here. It is a 2 variable. So in case of 3 variable, A and BC. So here we should write 0, 1 here, 0, 0, 0, 1, 1, 0 here and 1, 1 here. Okay. So the corresponding representation, decimal representation are presented inside the cell. For example, here you can see it is 0, 1, 1, it is 3. So 0, 1, 0, it is 2. So likewise, for 2 variable also the same procedure is followed. When it comes to 4 variable, A, B, C, D, it is 2 to the power of 4. So 16 boxes will be there. Okay. So here it is A, B, here it is C, D. So how we writing this values? So it is 0, 0, 0, 1, 1, 0 here, 1, 1 here. Okay. Likewise for C, D, 0, 0, 0, 1, 1, 0 and 1, 1. Now we have to number the boxes. Okay. So whatever the value that present here, we should represent inside the boxes. So for this binary value, we represent the corresponding decimal number. Okay. So that consider one example, 1, 1. Here it is 0, 1. So 1, 1, 0, 1. What is the decimal value? That is 13. Example for a 2 variable kmap. So we are provided with a value y equal to a b bar plus a bar b plus ab. Okay. So y that represents the output and ab are the input variables. So we should understand that it is a 2 variable inputs. Okay. So a b bar, this is 1, 0. Whenever a variable is given mean, we should write the value as 1. When its complement is given mean, we should write 0. So 1, 0, 0, 1 and 11. Okay. So then total input variables that is equal to 2. So the combinations are 4. So we should position this 1, 0, 0, 1, 1, 1. In that places, we should position the ones. After position the ones, we have to group that. For a 2 variable kmap, all cell combination, we should write the equation as x equal to a bar b, then a b bar plus ab. So when we solve this equation, we are getting 1. So in a 2 variable kmap, when all boxes are filled with 1 means we have group all the things, then the output is equal to 1. The 2 cell possible combination on a 2 variable kmap. So when we are going to group 2 numbers means what are the position we can group it here, here, okay, then here, then here. So these are all the combinations. So while we grouping, we should write the corresponding values. So after writing this, we should check the column. In the A column, all the values are same. Either it should be a 0 or 1, but all should be same. Whenever it is same means you write that value. Whenever if it is different means, here you can see in this B 0 and 1. So it is a different value. So put a X here. So we should consider only this 0. So 0 means it is A bar. Okay. Similarly here the same rules has been applied. This is one type of 2 cell possible combination. So here after we grouping, we are getting here 1, here 1, here 1. So we are grouping this 2 and this 2 and write the equation. Okay. Here it will be A bar. Here it is B. Whenever a 1 cell combinations can also occur, we can't able to group even a 2. At that time, if only 1 cell is present means we have to group that and write as a single term. Okay. For 3 variable kmap, we should write like this A, B, C. Okay. The table. Then for the corresponding values, this is of SOP form. So 110, 101, 111, 011, 010. So this is 6, this is 5, this is 7, this is 3 and 2. So we have to place all the ones. For all cell combination, the output is 4 cells possible combination. So this one, this one, this one, and also we can group this 2 and this 2 also. Okay. Similarly, we can write the equation. So whenever all the columns are same, means we should write the value, or else we put a X. So 4 cell possible combinations. Here the first row, second row. So the corresponding values has been written. Okay, here the 4 cell can be made, this 2, and this 2 can be grouped as a 4, or else this 4. This 3 variable kmap, 2 cell possible combinations can also be that. Okay, this 2, we can also group that. This 1, this 1 cell combinations are also possible in 3 variable. So if we group only 1 means we should write that corresponding equation. So now comes with the 4 variable kmap. So equation has been given. For that the corresponding value should be written. So 210 plus 1001 plus 1111. Okay, so we should find out what the values are. Then we have to place the ones. All cell combination, so all the cells must be placed with 1, so we can group together. So the output is 1. 8 cell possible combination. So in a 4 variable kmap, we can group this one, and this one, and this one. So this top row and the bottom row. Okay, so also the 8 cell possible combination, the first 2 columns, 2 3 columns, 3 4 columns. Okay, and the first and the fourth column. Okay, for 4 variable kmap, these are all the 4 cell possible group. At the same time, we can group this one also with this group again. So this one can be grouped with this group and with this second group also. 2 cell possible grouping is also there. Now going with that SOP form. Okay, first we should identify the expression. Then after identifying, we identify the total number of input variable. Then we have to construct the kmap for that input variable. Then place 1 in that particular mintab. As a simple example. So total input variables are 2. So we should draw this kmap. Then we place the ones. After placing the ones, we can group. So here we can group this one and this two. Second example. So it is a canonical SOP form. So a bar B bar plus A bar plus B. So we should multiply the missing terms. Here B is missing, here A is missing. So we should multiply that and we can get a simplified expression. For that simplified expression, we make the group. Given as a min terms M0, M3, M4, M6, M7 means we should write the corresponding binary values. So we place that ones in the values. So here it is 0, 3, 4, 6, 7. So this is 0 and this is 3 and this is 4 and this is 7 and this is 6. Okay. So when we are given with a 4 variable in this example, so whenever it's A, B, C, D, which means it is a 4 variable. So we have to convert them into a min terms and we place the ones here. So after placing the ones, we are grouping this 4 ones and this 4 ones. It can be grouped with again also and this one alone because there will be no more option. So this is another example. So 0, 2, 3, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have to place the ones here. All 8 we can group them as 1. Then this 4 ones. Okay. Then all the 4 corners has been grouped. Then this 2 1 and this 2 1. That can be grouped as 4. 1, this 2 ones and this 2 ones. That also we can form. So after that, likewise, every column we have to check. If all the columns are same means we should write that number or else put a x here. Then we move with the POS form, the product of sum form. So we know that this is the difference. Suppose we are given with the truth table ABC, 3 variable inputs, and these are the corresponding outputs. So wherever the values are 1 means we should write the equation. These are the min terms. Okay. So this is in case of SOP. 0 0 0 means it is A plus B plus C. For SOP we should write as A bar, B bar, C bar in a product. But here in terms of POS all should be again complemented like A, B, C. Okay. And instead of product in between them we should use the symbol plus. So A plus B plus C for this 0 0 0 and for this 100 A bar plus B plus C and for this 101 A bar plus B plus C bar. So it is M0, M4, M5. Reverse of this SOP is POS. Same case, a 2 variable kmap. Okay, the positions are same only, there will be no change, but instead of 1 we are using zeros. Kmap minimization using POS. First we should identify the expression, construct the kmap variable for the input variable. So placing the input in the kmap by place zeros in it. Okay, so an example of a 2 variable kmap. Okay, A bar plus B bar dot A plus B dot A plus B bar. Okay, so A bar plus B bar. So A bar plus B bar, that is a simple example of that AB. Whatever the thing that done is SOP, here it is in the reverse form. Okay, so A, B, that combination 0 0 they have mapped. Okay, A plus B means that is 0 0. So A bar plus B bar means both are 1 1. Okay, so this is 0 0 and this one is 1 0. Whenever it is not in the canonical SOP form means we should convert them into canonical SOP form. Multiply that input variable. We should add with that value and its complement. Okay, so B bar. Here B is missing, so we are using B bar. Add B bar. Okay, then apply the distributive law. Then expand this equation. Now the final expression we got is A bar plus B bar dot A plus B. Okay, so now we should map this. Similarly, for a 3 variable kmap, so 0, 3, 4, 6, 7. So capital M means it is a max 10. So we should position all the zeros here. Okay, group that. So this 2 one group, this 2 one group, and this 2 as another group. Then write the equations. So here the same rule. If the column is same means here we mentioned as 0, 0. Okay, then it is B plus C. That's what it's written here. Here it is B bar plus C bar. And it is A bar plus B bar. Came back for the 4 variable, put them into binary, and after that we place the zeros here. Okay, so this is how the grouping has been done. this two can be grouped and this two can be grouped. Then this one can be grouped. Okay. Finally, this and this can be grouped. These two are individuals, so we can't able to group with anyone. Okay. So after that, we solve it and obtain the following equation. As more than 5 variable means we should go with the tabulation or Queen-Mikkelsey method that we will discuss in the next video.